welcome to the stage, Sam Williams.
Appreciate it. As you said, I'm Sam Williams, and rather than explaining the title, let's just jump right in because it's a lightning talk. So this all began really when I was asked to write this function at work, greater than. Now you might be thinking that's a ridiculous function to be asked to write, but it did have these weird types. And if anyone knows this, I call these like interface any. I think lots of people sort of call it that, the any type in Go. Whenever I see that, I always just sort of think, is it time to learn, well, time to reflect. And what I mean by that is it time to learn Go's reflects package. And well, the thing is, with Go's reflect package, you might go to their blogs, their official blogs, and look at their introduction to reflection, and you see this. Reflection in computing is the ability of a program to examine its own structure, particularly through types. It's a form of meta-programming. It's also a great source of confusion. So after reading that sentence, I'm like, I'm going to try and do it without it, because that just seems ridiculous. So what I'll try to do, who loves this one? This is where you go, isn't it? You go with the type switch. Come on, that works great. Because all I've got to do, chuck in a case, chuck in all of the numeric the types. I'll have a little default where I'll say send an error back if it's not a numeric type. Well, I also need to do it for B, that second parameter. Same thing, all the numeric types. Default, if it's not, I'll send an error. And last but not least, I just simply return, the greater than. Issue is that is an error. It's a bit of that was a weird one. It's because turns out AT and BT don't get cast as any specific type. They're still just interface any, so you can't compare. But that's okay. I worked that one out. I'm just going to do it one at a time, right? Int first, and if you had a nice positive compiler, it would then tell you that worked really well. But compilers are never positive, they're only negative, which I think is sad. But either way, you've got to do then the int8s, and you've got to go all through them. So it ends up being a huge ungainly function, which is not fun at all. So you might be thinking, is there another solution? Can we do it with generics? Yes, you can do it with generics. I couldn't, because annoyingly, where I was writing this function, it's this thing called Go templating, which is probably another talk, but you can't use generics. So I was stuck with my big switch case. But that's okay, it's fine. I'm calling my greater than function. And it was working great until someone came along and wrote their own type. They called their type myInt, which was an int. They made some variables like this, and then when they chucked it in, what came out? Well, A is not a numeric type, which is not true, but it's not a numeric type that I knew about when I was writing the function. And so I'm a bit in a stuck situation here. But so let's have a think, what's happening here? What's the difference between the arguments and the parameters of the function? I think in Go we often think about things, in lots of languages, as having a value and a type. And so with our arguments, we've got value 1, say, type myInt. Over here, we've got value 1 type interface any, okay? And we can check that. Let's have a little look. I'm going to write here a little inline function. It basically is just a function that's taking the type myInt, and I'm passing in that parameter A. And as you can see, we nicely get told, cannot use A. Its type is interface any, and this needs to be a type myInt. So nice. Can also show you it if I just print out the type like this. I'll also show you that. Well, that does say myInt, so I was a bit confused. Why is the top one complaining it's not myInt and the bottom one is saying it is myInt? Turns out there's a bit of an argument going on here between two viewpoints, and the viewpoints are the top one is the compiler and the bottom one is the runtime, and they're disagreeing, and that's sort of the crux of reflect. So let's dive into it a little bit more. Where is that myInt gone? Looking at this model, we're missing something here. That interface any is not a type, it's the static type. Every variable in Go has one static type. It can never change. That's why it's a statically typed language. We love it, right? But it doesn't mean there's not a level below, deeper down. And here we've got something we could think of as the reflect type. And that is where you can find myInt. So let's have a little peek at how we can find it. I've got a variable here, which is A, interface any, variable I, which is myInt. If I make A equal I, A still got the static type interface any, but I can access this reflect type using this reflect.type of. And if I print that out, there's my myInt, okay? So that's how we sort of access it. So I'll chuck that in here. And as you can imagine, this switch on the type, it's not switching on the static type, is it? It's switching on the reflect type. It'd be sort of silly to switch on the static type. But the issue is, as we said, the switch doesn't work. I don't know about my int. So what can we do? Well, reflect has got our backs again. There's a level down, and that is called the reflect kind, okay? And how do we get that? Nice and easy. We take the type and we just call the .kind method on it. And what does that look like? Int. So there it is. I like to sort of think of that as like the primitive type, you know, the type underlying the sort of world of custom reflect types and all that. So, okay, great. How can I use kind to fix my function? Well, first bit is simply going to be, I want to check that the kind of A and the kind of B are the same. If they're not, chuck out an error. Then what I can do is I can switch, but this time I'm going to switch on the kind of A or B, doesn't matter, we know they're the same now. And I'm going to put a case in, and I'm going to put all of the different numeric kinds now. I'll put a little default and say if it's not a numeric kind, chuck an error. And finally, I can return A greater than B. But obviously that doesn't work either, right? Why does that not work? I haven't changed A and B. They're still interface any, it's still screaming. I know right now they're numeric, but the compiler is shouting, no, they're interface any and I can't compare them. So what can we do? What's staring right at that screen right now? You should be able to see it. It's what's filling this box here. If we've got reflect type on the right, what have we got on the left? Reflect value, nice. No, basically, what is this reflect value? How do we access that? Very similar example as before. This time, use reflect value of. I like that, nice and clear function calls, really good. And if I print that out, well, one, that makes sense. You wouldn't want the value to change, that's good. But crucially, if I print out the type of this, the type is this reflect value type. Now, reflect value, this is the confusing part of reflect. It's a struct with loads of receiver functions, loads of methods. What is it doing? The way I like to think about it is it allows you to do things that you would normally do with Go syntax with function calls. Now that probably makes no sense, so let me show some examples. Here I've got a slice, I can index that slice. If I make a variable that has the type interface any, and I make the slice equal to it, I can't index it anymore. But if I use the reflect value, I can call this index function, index 0, print it out, all good. So let's see another one quickly. If I've got a string, I make a pointer for that string. If I want to print out the string, I need to dereference the pointer. Very similar thing, if I make, again, this interface any variable, I now can't dereference it. You can't dereference an interface. But I can use reflect, get the value, and call that .lm, and boom, I can print it out again. So that's reflect value, but it's got one more thing that's really going to help us out. So if we go back to the problem, we've got A is greater than B, they're interface any. I need to, they've got the static type interface any. I need to create a variable with a static type that is the numeric type. So how do we do that? Well, the reflect value, here I'm calling reflect value on A, I can use these like int function here, say. And if I call that, what it's basically doing is creating a new variable for me, which has the static type of that int64, and the value is the same. So I can do the same with BT, and then I can do that. Finally, that it's not complaining anymore. Great. Issue is if I call int and it was actually a float, it would panic. So I need to be careful and make sure I do a separate case for the floats and a separate case for the uints. But that is it. We're solved. Here's the function. Okay, now you might be thinking, I was quite proud, it's not too big. It is quite big for something you normally do with one character. So do be aware, reflect is a bit weird. There's a lot that goes on in it, but hopefully this understanding makes it a little bit easier if you have to tackle it. So finally, just to say, we've got the value type, but it's actually that static type, that type that is only one, every variable can only be one type. But beneath that, we've got that other layer of reflect value and reflect type, that being the type that we're switching on that type case, in that switch case, and also is what we're printing out when we do a format print and do the T. And then deeper down, we've also got that kind, which is that sort of primitive type, and we can use the value to create a variable that has that primitive type to sort of be used. So that's my really quick introduction to reflection. You'll probably find it's way more confusing than that, but hopefully that visual idea will help you if you have to tackle something in it. So yeah, that's my talk. Thank you.